Welcome to the second half of chapter 45. So we're going to talk about hormones and we're going to pick up with our first structure, the pancreas. Now the pancreas is kind of cool because it does two functions. It does an exocrine function where it produces digestive enzymes, but it also serves an endocrine function where it produces glucagon and insulin. So two important hormones that regulate glucose levels in our blood. So the islets of Langerhans are just going to be part of the pancreas where these alpha and beta cells kind of live. And the alpha cells produce glucagon, and the beta cells produce insulin. So glucagon is going to be used when you need to make sure that the amount of glucose in the blood goes up, and insulin will be used when we need it to go down. Now, type 1 diabetes, or insulin-dependent diabetes, is where you actually have your immune system decides to go nuts and go after your islets of Langerhans, if you will, these cells, and so it damages your ability to make insulin. And so because of that, you can't make your blood sugar go down. Going up's easier. You don't have to worry about glucagon as much. If you kind of tell you're getting low, you can eat and you can boost it up. But it's much harder to get your blood sugar down. And so that's why they have to take insulin injections. Type 2 diabetes, you produce insulin, so it's not insulin dependent. This is more a receptor issue where the receptors start to ignore it. Usually it's because you've produced a lot of insulin for a long time and they just start to get tired of it. So your receptors just start to kind of react less to the insulin. And so then you produce more insulin, which makes it ignore it more until eventually you've got type 2 diabetes. So it's not that you're not making insulin, you might be making a lot of it. It's just that your body stops reacting to it as well. Now, this kind of graphic illustrates what's going on. So if we have low blood sugar, that's where glucagon kicks in. And the way this functions to go through and raise your blood sugar is it will allow the liver to go through and convert glycogen to glucose. So by converting glycogen to glucose, this glucose gets dumped in the blood. You now have more glucose in your blood. Blood sugar goes up. So this is good when you've been exercising, when you've been doing something that uses up sugar, and so you need to dump more in. Now, for most people, seeing as not many people exercise as much anymore, we've got more of an issue with the insulin aspect, where you go through and you have something that's sugary, whether it's like white potatoes, white rice, white bread, or any type of white flour, table sugar, high fructose, or any type of corn syrup, really, period. So any of those things will go through and start to dump a bunch of sugar into your blood. And that glucose, as it goes in your blood, can cause problems if it gets too high. Screws up homeostasis. Can kill you. Same with too low of blood sugar. So to maintain homeostasis, we dump insulin in the blood, which then makes the liver do the opposite, where it takes glucose and forms glycogen, which is just a polymer, if you remember, of a bunch of glucose, to get it out of the blood. And so this process just kind of usually goes back and forth, although some people tend to kind of abuse this process a little bit because we have so much stuff that's just full of sugar. And so that kind of makes this insulin aspect become an issue where we produce a ton of it, and then that can lead to type 2 diabetes. With most of our hormones, and you saw this with glucagon and insulin, they oftentimes occur in pairs, what we call antagonistic, where one says, all right, blood glucose, you need to go up. And the other one says, all right, blood glucose, you need to go down. And so this is pretty normal stuff. And so we'll discuss one other set where this happens. That's going to be regulating calcium in the blood. So with calcium in the blood, if you're trying to increase the amount of it, you can release parathyroid hormone, oftentimes written as PTH, from the parathyroid glands. So it's going to be these little dots that are on your thyroid. The thyroid is that guy that looks a bit like a butterfly that's kind of under here. And so you're going to release this PTH, and it's going to make your body retain calcium in the blood. So you're going to try to grab calcium from the intestines. You're going to try to make sure you're not excreting it in things like urine. You're going to try and remove some of it if needed, and shift it from like the bones and such into your bloodstream. This then raises the amount of calcium in the bloodstream, making it available for other stuff. That's PTH. Now, if you have too much calcium in your blood, calcitonin kicks in, which is made by the thyroid gland. And that's the one that ultimately is that butterfly-shaped guy that's behind the parathyroid. And so what this is going to do is it's going to do the exact opposite. It's going to make you not absorb it from the intestines. It's going to allow you more easily to get rid of it when you're going through and producing urine in the kidneys. It's going to make it where you are going to deposit it in things like the bones. And so it completely acts like the opposite of parathyroid hormone. Between these two, you can maintain homeostasis. If you get up too high, not a big deal. Calcitonin takes it down. If you get too low, shouldn't be a terrible deal. Parathyroid hormone can boost it up. The problem can be, of course, if you're too extreme, if you consistently have to keep adding it to the blood or removing it from the blood, you can get where in some areas you have too much calcium, like calcium deposits, which can be not the best thing ever. And you can also have where your bones can get weakened if you're trying to constantly parasitize it and take it from other places to boost it up in your blood. So this is one of those reasons it's important to have a balanced diet and not just constantly rely on your hormones to somehow make it happen. At some point, if they don't have the materials, you're just in trouble. Tropic hormones, I'm just going to bring up very briefly just to make you aware that a fair number of hormones, actually their only job is to help control other hormones, where they just tell some other hormone to be produced and go spread, and the other hormone might actually cause something. So for instance, thyroid stimulating hormone stimulates the thyroid, this is made in your brain, and it stimulates the thyroid to produce thyroid hormones like thyroxine, T3, T4, etc., these other hormones. But it doesn't actually do anything other than that. So it can't directly cause some end result. What it does is trigger somebody else who can directly cause some type of end result. Somebody else will activate some enzyme or activate transcription to allow this to happen. And then endocrine diseases, we can have screw-ups within this process that can lead to interesting stuff. We've already talked about diabetes type 1. So diabetes type 1 is a problem where you're not producing insulin. So that's definitely one of those issues. You can have where there's excess growth hormone, usually from a tumor that's resting against the gland that's secreting growth hormone, and so it makes it secrete a lot. And that can cause acromegaly, which basically means you get really, really big, you get really tall, and then even after you get to your max height, where your bones have sealed so they can't grow more, oftentimes the growth hormone will still make them get thicker, and that can cause complications as your bones keep getting thicker and thicker, and they're really not meant to. But that's basically a growth hormone issue. And then you can have hyper and hypothyroidism, where ultimately these thyroid hormones, T3 and T4, that kind of tell your body, all right, let's ramp things up, let's do this thing, you can produce too much of them. And that can cause a whole host of issues where you basically can't calm down, can't sleep, or you just crash because you're going, and then suddenly your body just kind of can't do more, and so it just gives in, versus the opposite of hypothyroidism, hypo meaning less, where you ultimately would be less active because your metabolism's sitting very low, and that could lead to things like weight gain, versus hyperthyroidism. These people would be eating 6 meals a day perhaps and not gaining weight. They might be losing weight just because they're burning so much fuel just to keep going because of all these hormones that are telling the body, hey, it's like we're at our peak, we're at max workout level all the time. And so your body just keeps shoveling the glucose, shoveling the fats in to try to provide the energy that your hormones are telling your body it needs.